Howdy. This video I'm going to take a look at a couple of low-cost multimeters that this company VENLAB sent me to check out. Um, they sent me a small little multimeter here and also a clamp meter here. I don't particularly have much need for the clamp. I mean, don't get me wrong, it's a wonderful tool. It's just a little bit out of my scope of work, but for around the house, I think that would be actually really good. Or maybe an automotive, if you check in coils or something like that, it might be useful. But yeah, let's take a look. I also had this guy come in, and this is actually something I ordered, and I had no idea it was going to be this big. I thought it was going to be a lot smaller. But this is just you know basically I call them resistance box. I don't know what they're really are, but you can set different resistances with them. Um, but first, let's take a look at this little meter they sent me. Now, I have already put the batteries in there, but I haven't done anything other than that. Now, this was their smallest, cheapest one, I believe. I think this one by itself is only $10. And the clamp meter here, I think this one is $40, but if you buy these two together, it's like $45, making this one like a $5 thing. And that makes sense. It reminds me a lot of the $5 Harbor Freight meter, actually. It's very reminiscent of that. So there's no auto range. Let's see, there's no capacitance. All we have is current, we have AC voltage, we have DC voltage, resistance, we have a diode mode and continuity mode, and then we have, I guess this is some kind of transistor tester. I don't know. I've seen them on the other meters, but I've never actually used it. Um, but yeah, I see emitter base collector there. So I guess that's something to do for testing transistors. I don't particularly have a THT transistor on me, and I don't feel like digging through my bin, so I'm not going to test that. But let's go ahead and test this resistance settings first, because in my work, that is my most used feature for a meter is resistance, diode mode, and continuity. But basically, that's all I use my meter for. And one thing I will say, I like these little probes. Now, I don't think these probes would be good for, heavy duty work, but for electronic repair, little probes like this are really nice. And it has a cap on the leads here, which, I like my leads cap like that because I like my point small, so I don't mess around too much. But they're not bad little leads. It says it's rated, it can do 10 amps. I don't think I would put 10 amps into it, but it's possible that it could do it. So let's set this to, I guess that would be 1 ohm, huh? And I'm going to set the scale to 200. Let's go ahead and probe it. Now, I haven't tested this box at all, so I don't know if the box works. And right now, this meter is saying 1.6. Let's see, everything should be set to 1. So I'm reading 1.6. Now, to see just how accurate this meter is, I know a lot of people, when they test meters, they like to use the same leads for all of their equipment to, you know, compare them, but I don't like to do that. I like to compare what I have, or what I was going to buy as a kit, with the other thing that I'm going to buy as it was a kit, because you might not have expensive probes. You might need to know exactly how this machine compares to a higher value machine. And that is what I'm going to do. I'm going to use my bench scope. Now, this cannot compare with the bench scope. My bench scope was, I don't know how much these run for now. I think they're like 1,200 still. They're pretty good scopes. I mean, meters. It's a little bit old, but they're still pretty expensive. This is the same as a Fluke. I think it's an 8044 maybe. Not sure. And I've also brought out my tech probes, very expensive probes. I don't usually use these unless I need a very good measurements because I don't want to ruin them because I don't want to buy more. But let's see what this guy reads. So this one reads 1.8. Now I'm more inclined to believe my tech, but this one actually is really close, and I'm disappointed if it's 1.8 because it's supposed to be 1. This is supposed to be a precision resistance box, and that's not very precise now, is it? Let's try 2. And this is 2.5. It's like I got a 5 on or something. So that should be 2.1. So the box is not doing very good so far. Now this should be 10, and it's 10.8. Okay, so that's my probe together, so it's not much happening there. Not too much precise about this box. Okay, so that's 100. Let's check now with this guy. Right at 100. So that's not bad at all. Let's try 200. Again, right there. Try 300. I got no reading for 300. Let's try 1,000. And I need to actually go up. So I'm reading 1,000. I forgot I'm not auto ranging here, so the 200 I can't go past. Let's go back now. It's not the box's fault. I forgot I wasn't auto ranging. So this should be 300. Yeah, that's good. Let's do 400. Close. 500. Pretty close. 600. That's plenty close enough for me for 95% of the time. It's not too bad for a $5-10 meter for sure. This is actually, I like the size of it. I like the feel. I mean, it's light, don't get me wrong, and it's plastic. This is some type of, I mean, this one is some type of little rubber, but very plasticky feeling rubber. Let's try continuity mode, see how fast it is. This should, oh, this is plastic, not metal there. That's why it doesn't work. So that's pretty quick. Let's see, 19. So this one will be continuity, right? Okay, now let's see. This should be here. Oh yeah, that is actually very fast continuity. I like that. That's pretty good. We can check something else. Let's see. What is this one? Power. Is that one power? No, I don't know what that one is. It's this one. Yeah, that's super fast actually. That's nice. Just for that alone, this meter is worth $10. For any electronic repair, that's your bread and butter right there, continuity mode. And I see it's got continuity and diode together, which makes sense. They're basically the same thing. So let's try it in diode mode here. So we had nothing, and there we had something. What happened to it? It disappeared. So maybe I'm just not doing the diode mode right. Oh, there it is. Okay, 4.5. That makes sense for this type of diode. See, these are gonna be some kind of Scotchkey or something. Signal diodes. They don't have a huge drop to them. I was looking. I don't know what on here might have a. Let's try this big boy. No, this is gonna be a signal diode. This one's not gonna have a big drop either. Maybe these guys. Can't remember what these ones go to. See, this one I thought was a Zener. I'm not sure why this one didn't read right. Maybe I didn't probe it good. So I'm not sure what's going on with this one in the meter. This I'm fairly certain this is a Zener diode. Let's see if I have any up here. No. All right. Well, that's probably something to do with that diode. I'm not going to hold that against the machine, but let's check this one. This is another just basic signal diode. Yeah, 0.45. All right, so I'm not really going to test the voltage too much. We can just check with my power supply a couple of different ranges. Nothing fancy. I'm going to pull the caps off here. Okay. And I'm going to hook in my power supply. If I can do it. And right now I should be, I'm on current. So let's go to 20 volts, I guess, for the range. And I have my box set at 13 volts. And let's see what Mr. Tech here says about that. I thought I had it pretty much dead on at 13. Uh-oh. Trying to get them both on here. And I am failing to do that. I should get a couple more alligator clips here. It might help if I put that on voltage. Okay, so here we have a bit of a difference. My text says it is 12.9. My power supply says I'm on dead at 13, which I'm not sure my power supply is calibrated exactly. And the VENLAB is saying 13.04. Again, I'm going to be inclined to believe the text go, but this is pretty damn close. So let's take it up to 23 volts. So I'll have to move up a range into the 200. And yeah, they're both reading dead on. So my power supply says 23 volts. Tech says 23. And the VENLAB did an excellent job as well at 23. Now this power supply only goes up to 32 volts, so we can try that. And same thing. So 23, 32, they were all good. Yeah, actually, for $10, that's not a bad scope at all. It's not going to be something you'd work with every single day, but if you just like to poke around your electronics, or you want to start poking around, but you don't want to invest a lot of money, I can't lie, man. That's pretty good. Pretty good little meter there. So yeah, I'm going to take a look at the clamp meter as well. I'm just going to kind of do the same thing. But if you're not looking to spend much at all, this guy for $10, that's that's the cat's meow. You can't do much about it. This guy is 40, and the nice thing about this one, I come with a thermocoupler too, so you can measure temperature. This one has a few extra settings, so if you don't mind spending a little bit more, you can get a lot more for your money. So this one, at $40, you have the clamp meter, which is pretty neat. You can put it around a wire. So like if you're, let me demonstrate the clamp meter here. Now you can't clamp it like this. You can't clamp two wires. You can only clamp one. Okay, now if we short this, let me turn my current down. Let's turn it down. I'm going to put it at 1 amp. And let's turn the voltage down because that's just too much voltage. Let's turn that down to like 1 volt or something. Okay, so I'm going to put this on amp. Let's just do the 600 range. And let's see if it goes up to 1 amp. Oh, you know what? For DC, you have to for DC, you have to zero it first, I believe. And I am on AC, so I'm gonna hit function, go to DC. I'm gonna zero it. Now let's try again. So for whatever reason, my meter is saying 0.76 amps, and this is pretty close. This is 0.75 is what it was first reading. Kind of fluctuating depending on how I hold the wire, but if I put the wire right in the corner, it's dead on. So that's pretty neat. But again, I don't have much use for clamp meters for my basic repair work. Usually, I know what my current is just based off of my meter. Which this one has a lot of other functions too. So it has your typical voltage reading. So I need to get the probes for it. So this one comes with a little bit bigger probes, and these ones don't have a shield, which truthfully, these probes may be a little bit more heavy duty, but truthfully, I like the other little probes better for like around the house and electronic work. But these ones are nice. These ones are meant to be a little bit heavier duty. Um, so I guess we'll check this box again, or we can check voltage. So right now I'm at 1 volt, so we should be able to see this. Am I set to DC? I am set to DC. I'm at 1 volt, so that's pretty accurate. That's 0.99. We'll call that 1 volt. We can turn it up. So 3 volts. That going up to 4. That's 5. Okay, let's change it to 10. Okay, let's change it to 20. So yeah, it's reading voltage pretty good. Pretty solid there. Actually, reading a little bit better than the other one, I think. The other one at the lower ranges was a little bit off. But yeah, that works just fine. Let's take a look at the other function. So this one actually has capacitance. Oh, this is temperature. I don't know what I'm doing here. But this one, if you hook up the thermocoupler, you can do temperature reading. So this one does frequency too. I guess I could try that with a signal generator. Oh, you know what? I don't even need to do that. I'll just use my oscilloscope, the calibration thing for my oscilloscope. Let me see if I can put this where you can see it. Okay, so I'm going to measure the hertz here. And you should be seeing 1 kilohertz. Can't see what it says. Yeah, well, yeah, this is saying 1,000 hertz, which is 1 kilohertz. So that's pretty neat. That is actually very useful to have on your meter if you're poking around electronics. Every once in a while, you'll need to measure, the frequency of a signal. Most everything I work on is automotive, so it's almost all DC signals, and a lot of, logic signals and stuff like that. So that's actually pretty useful. But here, this function, we have a diode, we have a continuity, we have resistance, and then we have a capacitor. So when you first go to it, you go to auto ranging for resistance, which is nice. Let's just auto range here. Let's go to 3,000. Okay, that was good. Let's go to 30,000. Okay, let's see if we do 90,000. But all right, so that is the resistance. That was working fine. The next function is continuity. which, like I said before, is my most important one. So let's go back here. Let's do the same test. So this is 19, and that is pretty quick, just like the other one. Yeah, that is plenty quick enough to do what you need to do. Okay, next function is actually capacitance. I'm surprised. I thought it would have been diode mode, following this circle around, but it's actually capacitance. And I do have some capacitors here to test. So let's try that. This one, I think, is 200 or 220 UF. So 225. And now let's check and see how accurate that is. I'm going to pull out a pretty accurate meter here. Let's change the frequency to 120. So this one was 225. I'm not sure what frequency it was measuring at, though. You can get a lot of different readings with different frequencies. So this one is at 213. I'm going to check the different frequencies. No, I get the same reading for... I'm assuming that it was at 100. Usually they're at like 100 or 120. But that was reading a little high. So let me check on this one. This one is 100. And let's see how this one reads here with this meter. So that's pretty low at 87. That's supposed to be 100. Now let's check on this one. And it was, the other meter was reading 87. This one is 92. So the capacitance is a little bit high, but that's not a big deal. And then we have our diode mode. The last thing I'm going to check here. I wish I didn't have such a bad reflection. But still, same diodes. I'm looking at the same thing here. So it's all those smaller voltage drops. And let's check this guy, see how he does. Maybe this thing is bad. Maybe I need to repair this. I don't know. Okay, so it's just pretty small. The other meter was dropping out when it was this low, I think. Let's check again, because I'm curious about that. Because that's a bit of an annoyance if that's not going to read. I remember seeing that flash up and then it just disappeared. So I'm in diode mode, and yeah, see, it shows up for a second and then it just goes open circuit. Maybe if I wait a little while. Yeah, see, I think this is a problem where it's got continuity mode and diode mode together or something. So that's kind of not too good, unfortunately. Like, it will show it for a second and then it just loses it. And I imagine it would be like that for any smaller, voltage drop diodes like that. Let's check again. So yeah. Everything else looks good. With that, I would have to say you're gonna do a little bit better to step up. But at 45 bucks, I mean, I would just get both, to tell you the truth. They're definitely very useful to have around if you don't currently have one. So not too bad. I definitely want to thank VENLAB for sending these out to me to test, and I'm going to toss this one into my work van for my mobile job. So yeah, I'm actually going to put this one to good use, and maybe eventually I'll get to play with the clamp meter a little bit more serious. But again, thank you, and thanks for watching.